Okay, good morning. So today we're going to talk a little bit about speed and velocity. Speed and velocity for all our purposes today are going to be the same thing. However, they're actually not exactly the same thing. We'll talk about a little bit more about what the difference between them is on Friday. We'll talk about the difference between displacement and distance, as well as what a vector quantity is. But for now, and just for today, we're going to be doing some calculations, and we can use velocity and speed the same way. I mean, it's pretty much the same thing. Okay. All the equations to the right are also essentially the same. Basically, speed is just distance divided by time. So distance over time. So the distance traveled over the time it takes to travel that. And the units for distance and time are really, they don't really matter. It's just whatever they are asking you to find. So if they want it in kilometers per hour, you do it in kilometers and hours. If they want it in meters per second, use meters and seconds, and so on and so forth. Just whatever units are specified. Okay. Now, you also might see it this way with the delta. This little triangle is called a delta. So delta distance over delta time. And this just means change in. So change in. Okay, oftentimes it's represented as like final minus initial, or that's actually what it is. It's final minus initial. Okay, you may have seen this before in change in y over change in x, which is this formula for slope, right? So you have y2 minus y1 over x2 minus x1. Okay, and 2 comes after 1, so it's like final minus initial, same kind of thing. Okay, when we talk about speed, we can talk about the change in x over change in t, so we can use x instead because x is basically the horizontal change in this distance, right? So we change in x over change in t. If we're talking about vertical, like dropping something, we say change in y over change in t. Okay, it really doesn't matter. It's just a change in distance over change in time. Okay, really that's what we're looking at here. Okay, you also might see that these little xf minus xi, f means final and I means initial. Okay, it's always final minus initial. Okay, so that's the formula we're going to be using today. Let's talk a little bit more about speed and velocity. What's the difference? Again, we're really going to get a little bit further into that on Friday. But again, speed is the distance an object travels divided by the time. Okay, it's scalar, meaning it does not have a direction, no direction. Okay, scalar means no direction. All right, velocity is the displacement. So displacement and distance are a little bit different. I'll talk about what those are again on Friday. This displacement divided by time, and it's a vector. Vector means it has a direction component to it. So you'll either say right, left, up, down, north, south, east, west, backward, forward, sideways, whatever. And we'll talk about how that has to have a reference point too on Friday. Okay, but for today, we're just going to be doing some calculations, some of the math, and we're just not really going to worry about the direction. Velocity and speed will be the same thing. Okay, you also might see the units. The units are typically distance over time, so meters over seconds. You can also write s to the negative 1, so meters s to the negative 1, because anytime you have s to anything to the negative 1 power, it's 1 over that. So these are essentially the same thing. When you write it on for anything on your work, you can write it any of those ways. You can write it meters per second, or meters per second, or meters times seconds to the negative 1. All of these are acceptable. They are all correct. They all are used interchangeably. There's no one right way to do it. Typically, a lot of people will write it this way if they're writing it in a paper or typing it. It's just easier to type up that way. And if there's other with other formulas or other constants, it's sometimes easier to write it like this. Okay, but it doesn't matter to me how you write it. Totally up to you. All right, now when we do these problems, we have this main equation here, velocity equals distance over time, and I'm going to use that equation every single time and just manipulate it, or just kind of move the variables around to get the other two equations. Okay, I don't like to memorize these things. I just kind of figure them out as I go. Okay, this is the only one I memorize. Memorize this one, and then I figure these ones out if I'm looking for distance or time. Okay. Now, when I solve these problems, I want to highlight in yellow or circle all the known variables, and highlight in green or box where the problem is asking to solve. Then I'm going to write out the variables, their values in units. I'm going to convert any values to common units that I need to, so that all the units are the same. Then I'm going to write out the formula, so this v equals d over t, and solve for the variable that I'm looking for. And then I'm going to plug in the values and solve. And actually, when I do it, I actually do 4 and 5. I actually kind of switch and do them all in one step. But you can do it however you want it. As long as you show the work, it doesn't matter to me. Okay, and then when we get the answer, we box or circle our answer and include the units. Okay, so let's do that with this first problem. The first problem is really simple. Okay, so horse trots 20 kilometers, 2 hours. So those are the two known things. We want to know the average speed. Okay, so I circled the two things I know, box the one thing I'm trying to find. Then I'm going to write out all my variables. I know the distance is 20 kilometers. I know the time is 2 hours. And I want to know the speed. And I know speed is distance over time. Or really, actually, let's just do it this way first. Speed equals question mark. And we want to know kilometers per hour. We weren't really given units, but because we have kilometers and hours, I know that the units will be kilometers an hour. Okay, and then I'm going to write out my formula that I need. I need speed equals distance over time. And this is already solving for what I'm looking for. So I can just now plug in my values. Distance is 20 kilometers. Time is 2 hours. So I get 10 kilometers per hour. Doesn't matter how I write my units, 10 kilometers per hour. I'll write it all three ways. All of those. Circle or box my answer when I'm done. It's super, super simple one. Next one. Okay, a baseball travels 20 meters. That's our distance. In 5 seconds, that's our time. What is the baseball's average speed? So we're looking for average speed, but we also need it in kilometers per hour. So keep that in mind. I'm underlining that. I didn't really put that in my directions there, but that helps you remember what units I'm looking for. So distance is 20 meters. Time is 5 seconds. And we're looking for speed. And we want it in kilometers per hour. So first of all, we need to convert these. So we need to convert meters to kilometers. So 1 kilometer is 1,000 meters. So we get 0.02. Then move it over 1, 2, 3. 0.02 kilometers. And then 5 seconds, I'm going to convert that to hours. So 60, what was that? I don't know what that was. There are 60 seconds in 1 minute. And then in 1 hour, there are 60 minutes. Okay, and I'm going to do that math there, and I get 1.38 times 10 to the negative third hours. Or 0.00138. Okay. All right, now I'm gonna plug it in. So I know that speed is distance over time. The distance is 0.02 kilometers. The time, 0.00138 hours. 0.02 divided by, that is 14.4. There we go. All right, next. Okay, we have a car traveling 30 kilometers per hour. That's our speed. How far? So we want to know how far. That's our distance. And 2.5 hours. That's our time. So speed is 30 kilometers per hour. Distance we don't know. And our time is 2.5 hours. Okay, our formula is speed equals distance over time. But we want to solve for distance here, so we'll multiply both sides by time. Okay, so essentially speed times time equals distance. Okay, and all our units are fine. I didn't mention that, but they all are fine. So 2.5 hours times our speed, 30 kilometers per hour. And we get 75. 75, and then hours cancels, and we wind up with kilometers. Easy peasy. Next one. Okay, truck traveling 45 kilometers per hour, so that's our speed. How long? We want to know what the time is going to be. Will take to go 150 kilometers. Okay, so our speed, 45 kilometers per hour. Our distance is 150 kilometers. And time is what we don't know. So here we're solving for time. So our formula is speed equals distance over time. This one's a little bit trickier. So I got to multiply by time first. That cancels, but I got to do it to the other side as well. And then divide by speed. And divide by speed. So essentially time equals distance over speed. The distance is 150 kilometers. The speed is 45 kilometers per hour. So 150 divided by 45, I get the distance to be 3.33. Sorry, the time to be 3.33, and hours will go up to the top here, so 3.33 hours. Okay, last one here. Kind of putting it all together here. So how many kilometers? So we're looking for a distance. Will car travel 30 minutes? So that's time. It's moving at 10 meters per second, so speed. So speed, 10 meters per second. Time is 30 minutes. And we want to know distance, but we want to know in kilometers. So first of all, we got to convert this 10 meters per second into kilometers per second. So we want to get rid of meters, and we want to get kilometers. So 1 kilometer is 1,000 meters. So we'll decimal over 1, 2, 3. So 0.01 kilometers per second. And then we got to convert 30 minutes to seconds. So we have a common unit here. So there's 60 seconds and 1 minute. Those cancel. So we get 1,800 seconds. Okay, and then we're going to use the formula. So speed equals distance over time. But here we're looking for distance, so multiply both sides by time. So speed times time equals distance. So the time was 1,800 seconds. Our speed was 0.01 kilometers per second. And seconds will cancel. And then we got to move it over 1, 2. So 1, 2. So it should be 18 kilometers. There you go. Okay, now go ahead and practice that. See if you can do it. Questions, let me know.